Yeah, I mean, I think the open source projects are like fundamental building blocks for scientific research development, our community, and of course this conference. So, and a lot of things have happened since the last SciPy. So we're gonna take the next, I think, 25 minutes to hear about the awesome updates from these projects. Yeah, so let's get started. First we have NumPy, and after that we have Awkward Array.
Hello, SciPy 2024. I'm Inessa Posson, and I'm a NumPy Steering Council member. And my co-presenter is Chuck Harris. Chuck, come here. To the microphone.
Oh, you want me to do it?
Yes. Not all of it.
Okay. Yeah, I don't really know what's here, but the main thing on NumPy is the release of NumPy 2.0.
Yes, let's start with the big news.
And that's a big jump. We've been on NumPy 1 point something since about 2005. So it's almost 20 years, and we've accumulated a lot of crud and learned a lot of things we wanted to do. And so that's what 2.0 is about. We've removed a lot of stuff that are duplicates. We don't think needs to be there anymore. And we've tried to make it easier to extend the NumPy data types, because that seems to be the way of the future. But that's really the big news. From my point of view, the other thing that's good is that we have a fair number of paid people working on the project now, which is a big change.
Thank you, Chuck. And just to make sure that everyone in the room knows, on GitHub, if you ever contributed to NumPy, that would be C. Harris. And Chuck has been release manager for NumPy for how many years?
On and off. My first release was NumPy 1.1.1, 1.1.1, that was in 2008.
Okay. And this is first time I convinced him to come on stage and give an update on NumPy. So please give him a round of applause. And a few more words about the big news about the NumPy 2.0 release. It is a result of a collaborative effort, largely volunteer, effort spanning many years. However, some of these changes would not have been possible without our funders and the institutional sponsors, allowing several team members to work on NumPy as part of their day jobs. And I would like to acknowledge our supporters, the Gordon and Betty Moore Foundation, the Alfred P. Sloan Foundation, NASA, NVIDIA, Quantsite Labs, the Chan Zuckerberg Initiative, and Tidelift. Thank you. We knew throughout the planning and development of this release that rolling out NumPy 2.0 would be temporarily disruptive because of the backwards incompatible API and ABI changes. The team put in a lot of effort in communicating these changes, helping downstream project adapt, tracking compatibility of popular open source projects, and completing the release process at limited pace to provide time for adoption. We realize that for some, Monday, June 17th, the day after the release, got unexpectedly very busy with addressing the issues related to the release of NumPy 2.0. I hope it was manageable, and 4 weeks later, your software is on track. Today at 1:15 p.m., we are hosting a Birds of Feather session for you to share your feedback on the NumPy 2.0 release, bring your questions, comments, suggestions, and opinions. And just a few words about documentation team and web team. Marsley is working on more comics about contributing to NumPy and the SciPy ecosystem as part of 2024 Google Season of Docs. And the NumPy web team is continuing the partnership with the Scientific Python project. The Scientific Python Hugo theme is now available for adoption. If you are considering to build or redesign your project's website, check it out. And please connect with us. Quite a few NumPy team members are here in the building, so please come up, say hi, come to our Birds of Feather session, and share your thoughts on the project. Thank you.
Thank you, Anessa and Chuck. Next up, we have Awkward Array, and Jim Pewarski will be presenting about it.
So yeah, Awkward Array. For those who don't know about this library, what is it? It is a library for manipulating JSON-like data with NumPy-like idioms. So if you have data that's complicated like this with nested records, variable length lists, and such like that, you can slice it, map it, reduce it, and manipulate the data using the same kinds of APIs that you would use for NumPy. So what's been happening? First is that we finished all of last year's development goals. I went back and looked at the slide I gave it this track last year, and everything that was in progress or to be done has all been done, including finished documentation. So if you looked at the documentation in the past, there were some to-dos that maybe led to the impression that it was less mature than it is, but those to-dos are all done. Everything has been filled out. By the way, if you go to awkwardarray.org, notice this orange Try It button. You can try Awkward Array in your browser. We have a nearly complete GPU backend. This is the thing that I hope to say next year. This is also done next year. We've had a first wave of users. Most of these users are in particle physics, testing Dask Awkward at large scales. So Dask Awkward is a new component that we've had our first wave of testing, and now this is moving outward. And this is part of a growing Awkward family. I can't resist the pun. Libraries that are extending Awkward Array by as separate packages. Dask Awkward is the first. There's awkwardarray.jl in Julia for sharing Awkward Arrays between Python and Julia. Ragged is a subset of Awkward Array that adheres to the Array API specification. There's a backend for Katai struct if you have weird file formats, and Akimbo that I hope to talk about in a lightning talk later today is an Awkward Array accessor for all the data frames, Pandas, Polaris, QDF, and such. Third question, what are people using it for? It is still mostly used in particle physics. So we went and searched GitHub for import awkward, and we find a lot of use cases in particle physics and a growing number of use cases outside of particle physics. And I want to just list some of the libraries that we found import awkward in to show the kind of diversity of the kinds of problems that it can be applied to. And with that, that's it. Thank you.
Thanks, Jim. Yeah, my name is Sanket Verma, and I'll be presenting on ZAR. So for those who do not know what ZAR is, it's basically a way to store your large out-of-memory arrays, dividing them into small parts and then compressing them. And we call these small parts essentially chunks, and it's basically based on a specification, so it has implementation in all the prominent languages. So if you are not a Python user, yeah, please try us. Since SciPy, there have been a lot of things happening in the ZAR ecosystem. We accepted the sharding proposal, which is like the ZEP proposal, which stands for ZAR Enhancement Proposal. And it lets you basically club your multiple chunks into like units known as shard. And this thing is very useful when you are dealing when you're dealing with high latency storage and for input-output operations. So let's just say Google Cloud Service or Amazon Azure or sorry, not Amazon Azure, AWS and Microsoft Azure. If you want to read more about it, you can go to this QR code about the proposal. So yeah, after that, we established a working group to add v3 support in ZAR Python. And there are few things which are very, which I would like to mention here for the v3 support in ZAR Python, that it offers async functionality. So v2 didn't have async functionality in ZAR Python. So it basically lets you have multiple reads and write operations at the same time. We have added like type support throughout the v3 code base. So yeah, the code looks much neater. ZAR Python v3 has v2 support, so it's like backward compatible. You can read your v2 datasets. We did the first release on June 11th, and which includes sharding, and the second alpha is coming anytime soon. The full release is expected by the end of this summer. So if you wanna try your hands and see and report any issues, so yeah, please go ahead, pip install zar equals this. And as for the community part, there has been things happening over there as well. So we officially moved to Zulip chat. So any Zulip chat fans in the audience? Yeah, awesome. And so basically this is like a screenshot of our homepage, and this was offered to us by this initiative Open Source Science, which is in collaboration with IBM and NumFocus. This is a QR code if you want to join us. We had a couple of meetings over at University of Washington and New York, and there have been a lot of code and discussions happening over there. Recently, there was a big release of 6 petabyte of public SAR dataset, which was released by Google Research. So there's a tweet, thanks to Stefan and his team. If you wanna check out the dataset and the GitHub repository, please go here. I think this is the largest public SAR dataset out there. So yeah, thanks to the team. And a couple of new implementations in our Rust OCaml. Logos are trademarked. We have new blog post, and we have meetings, bi-weekly meetings, so you can join us and office hours. So thank you, everyone. Next up, we have Elliot for Matplotlib.
Hi, I'm Elliot. You may know me as QLogic on GitHub. Going to talk about Matplotlib past year. So since last SciPy, we had 2 Mesa releases. We changed our versioning scheme to effective versioning instead of semantic versioning, so now we call them Mesa releases. And a variety of bug fix / micro releases since then. In 3.8, there'd been some statistical things, so these are I forget what the acronym is, but ECDFs, and there's some math things that I don't understand, but I'm sure they're important to some people. Other than me. We had several math text improvements thanks to our Google Summer of Code student, Ratna Bali. So she did several nice things to add things that have been broken or otherwise not spaced correctly and missing things that are not in our math text. And so that's been really nice for people using this math stuff. The other big thing in 3.8 was type hints. So we did something that I know the simple signature looks longer than the complex one, but my point is that the simple one is stuff that basically just works as a straightforward type, whereas complex are stuff that might be overloaded. So we try to do our best to handle the wide range of ways you may call plot, but unfortunately some things are not possible that way. But hopefully they are getting better and better as we move along with releases. In 3.9, we had added legend support for boxplot, so you can basically give labels to your boxplot call, and the legend will automatically pick up the styling from the boxplot that you have. We got individual hatching for stack plots, so you can pass the hatch parameter with a list of styles, and you get that output directly on the right side you see there. And this is a PR from a new contributor this year. And then another change is the violin plot size. So this is a very straightforward thing that used to be in Seaborn, but now we have it in Matplotlib proper. Again, another nice straightforward PR from a new contributor, so we like to acknowledge those people. Upcoming features, we have multivariate color mapping in the works. This is by Trygve, who's one of our Google Summer of Code, or our only Google Summer of Code student this year. And so this is enabling you to use 3 different color bars to basically map onto your data set. You can see on the left there's a color bar made of 3 variables, and on the right there's a 2D thing. And so we're really looking for other domains that have use of multivariate color mapping, because we want to be able to provide an API that's really useful for everybody, regardless of what domain you're in. We are going to be holding sprints, and we have some work that was done on example categorization from our Google Season of Docs by Ava last year, and we're going to try to get tagging for examples, so that way you can look up what examples talk about animation or what examples talk about axes, etc. And so please come to our sprint to work on that. They're nice, straightforward new contributor PRs that you can do, and they won't be too complicated to get your feet wet in contributing with Matplotlib. We have our new contributor meeting on the first Tuesday of the month. There's a QR code. You can get the link to our calendar. And I always end up this presentation by pointing out that I made it in Matplotlib. You can get the link to the slides on the QR code on the left and link to our release notes on the right. Thank you.
Thanks, Elliot. Next up, we have Peter from Napari. Napari.
Good morning, everyone. We were first. Yeah, my name is Peter, and I'm representing Napari. Y'all were probably expecting Juan, so sorry for the bait and switch. If you're not familiar with our game, Napari is an n-dimensional image viewing application in Python. One of the coolest things, I think, is that we have bidirectional support between the Python API in the kernel and then the GUI that's happening. You can visualize, annotate, explore 3D datasets and ND datasets. And we have over 400 different plugins in the plugin ecosystem, which is pretty awesome. The past year, we've had 2 releases. 0419 was mostly bug fixes, but also implemented a lot of the color processing for labels on the GPU. It was a big whack-a-mole. And then today, 050, finally releasing from main again after over a year. Don't ask. But we have new async loading, which is really nice. NumPy 2 support, fully supported NumPy 2. For plugin developers, you can contribute your functions and widgets into the various menus. It makes it easier for users to find your stuff. And then plugins can install from CondaForge. So if you have compiled dependencies, that makes your life a lot easier, or the user's life easier. Lots of bug fixes and quality of life. Bigger news, we gained 3 new developers. This is like huge from a sustainability point of view. I want to welcome to our team Alyssa and Voter Michael and Lucy. And you can see from the map that we span a lot of the globe now. So the Zulib chat, which is like a better Slack, it can be pretty active almost at all hours. So no matter where you are, whenever you want, chat with us, come check it out. What's coming up? Well, we're going to have a faster release cycle because we're releasing from main again, right? So that'll be good. We have a new layer type coming that's a graph layer for looking at graph data. There's been good progress on layer groups, which should be really nice for people working with multiple modalities. You can make things work a little bit better by being able to group those together. Multi-scale rendering in 3D, you could see that prototype there. And then multi-canvas rendering is also on the docket, along with improvements to units and spatial transforms. The last thing I want to say is that we are going to work on instance rendering, and we have some financial support for this. So if you know OpenGL or VisPy, and you want to contribute and want to make some dollars, please reach out, contact me. And there's the roadmap. So thank you.
Thanks, Peter. Next up, we have Dan from NetworkX.
Hi, I'm Dan Schult, and I'm talking today about NetworkX and our updates in the recent past. I want to give a little bit of a plug for network analysis. Often you look at your data set and you think, oh, I don't work with networks, I work with databases. But a node can be anything as long as it's connected in pairs by edges, and that makes it a network. So your node can be people, but in a more abstract way, the nodes could be variables. If you're looking at relationships in a binary way between 2 variables at a time, you've got a network. So that's the end of my plug. NetworkX is a network analysis tool. We look at algorithms. We do have some visualization, but it's very basic. Most of what our emphasis on is for network science algorithms. The idea is to be simple and yet powerful and flexible. You can read more at networkx.org. This year, we've had 2 major releases. We have a new dispatching system. And what does that mean? If you've ever used NetworkX and ended up it being too slow, there's hope. We have a back-end system where the back-end comes in and can essentially hijack any NetworkX function, convert the NetworkX graph into whatever graph format they want, and apply their version of the function, return the value, and you get it back as if it was a NetworkX call. So the result is that you have an environment variable switch, which can turn your NetworkX code into running some specialized back-end code or data structure. Some examples: here's a cuGraph back-end where you can use GPU-based algorithms to, for example, compute PageRank or some other measure of the importance of nodes or something like that. There's also an NX parallel backend, which uses joblib in the background so that your CPU's multiple core system can be taken advantage of. And graph loss algorithms doesn't use parallel computation, but uses different kinds of algorithms that are written in C rather than the Python dict structures that NetworkX uses, and so that speeds up many of the algorithms as well. In addition, over the past year, we've introduced new and also improved some algorithms. Causal graphs are, we have a number of new functions in that arena where you're trying to figure out which variables are independent of each other, which ones can cause dependency between them. We're always working on community algorithms. It's one of our most popular areas, and so we have some new algorithms in community detection. Graph generators, and then edge coloring is we've done lots of node colorings before. This is edge coloring. What is coloring? You're just grouping the things without any overlaps. You want to make sure that the groups don't overlap each other. What's coming for the next year? We're going to be focusing on, we have some funding to help us focus on some new community detection, including a Leiden, if you know that word, work. And then we're going to update our Louvain community detection algorithms as well. We're going to be looking at subgraph isomorphism, whatever that means, right? Well, I'll try to tell you what that means. Finding copies of simple networks inside your big network. And these are very useful for trying to describe the health of your system. What's normal? How many of these little copies do you have normally? And if that changes, does that help you predict that something's breaking? We're going to be spending a fair amount of time on an improved visualization interface. This does not mean that we're going to become fantastic at visualizing networks. I don't think that you can become fantastic at visualizing beyond a hairball. That's what we're trying to do. But our API is fairly basic, and we want to improve it. And so we're going to be working on that. And of course, we're going to be continuing to develop this dispatching system that we have. In particular, we'll be working on caching function call results so that you don't have to call them again, and easy configuration control of the back-end parameters from a NetworkX configuration model. And of course, most of our time is spent with bug fixes, maintenance, and documentation. So that's what I have. Thank you.